There's a structure in the universe so large that it would take 10 billion years traveling at the speed of light to cross it. It's not a galaxy. It's not a galaxy cluster. It's something that connects everything that exists in the cosmos, and you're inside it right now. In 1989, astronomers observing the night sky made a discovery that would forever change our understanding of the universe. They expected to find galaxies randomly distributed through space, like stars scattered on an infinite beach. But what they saw was completely different. The galaxies formed patterns, giant lines, colossal walls, and between them, nothing. Absolute voids larger than millions of galaxies combined. The universe is not a uniform ocean of matter. It's a web, a three-dimensional network of incomprehensible proportions that connects every particle of visible matter since the Big Bang. Scientists call this the cosmic web, and it's the largest known structure that exists. To give you a sense of scale, our galaxy, the Milky Way, is 100,000 light years in diameter. Seems immense, right? But it's just a microscopic dot on a single filament of this web. A filament that can extend for 500 million light years. And there are billions of these filaments crossing the observable universe. If the idea that you're floating inside the largest structure ever discovered blew your mind, hit that like button and subscribe to the channel. Because what you're about to discover in the next few minutes will completely change the way you see the cosmos. Let's go back to the beginning. How did scientists discover that the universe had this hidden architecture? In the 1970s and 1980s, telescopes began mapping the position of thousands of distant galaxies. Researchers measured something called redshift, the shift of light toward red caused by the expansion of the universe, which indicates how far each galaxy is from us. When plotting these positions three-dimensionally, they expected to see a more or less homogeneous distribution. But in 1989, Margaret Geller and John Huckrow from the Harvard-Smithsonian Center revealed the first deep three-dimensional map of a universe. And there was a giant wall of galaxies, which they named the Great Wall. Over 500 million light years long, 200 million wide, and only 15 million thick. It looked like a cosmic sheet floating in the void. And that was just the beginning. As the maps became more detailed, the pattern repeated in all directions. Galaxies clustered in long, thin filaments. These filaments met at nodes, giant superclusters containing tens of thousands of galaxies. And between the filaments, voids, immense regions of space with virtually no galaxies. One of these voids, the Boötes Void discovered in 1981, is 330 million light years in diameter. To understand, if the Milky Way were in the center of this void, we wouldn't be able to see any other galaxy with the naked eye in the night sky. We would be alone in absolute darkness. The structure looks exactly like a three-dimensional sponge, or cosmic scale soap foam, thin filaments forming the bubble walls, dense nodes where the walls meet, and giant voids forming the interior of the bubbles. But here's the question that keeps cosmologists awake at night. Why does the universe have this shape? The answer is hidden in the first 380,000 years after the Big Bang. At that moment, the universe was a hot, dense soup of particles. But this soup wasn't perfectly uniform. There were microscopic quantum fluctuations, regions infinitesimally denser than others. When the universe cooled enough for light to finally travel freely, these fluctuations were frozen in space like a cosmic fingerprint. The cosmic microwave background radiation, which we observe today coming from all directions, shows exactly these fluctuations. Their temperature patches that vary by only 0.00001 degrees. Seems insignificant, but these patches were the seeds of the cosmic web. In the slightly denser regions, gravity began pulling more matter. In the less dense regions, matter was sucked outward. Over billions of years, this process created the filaments we see today. Matter flowed like invisible rivers through space, following the paths of least gravitational resistance. But there's a crucial detail. 85% of the matter forming this web doesn't emit light. It's dark matter, a mysterious form of matter that we only detect through its gravitational effects. The galaxies we see shining in the filaments are just luminous tracers of a much larger, invisible structure made of this dark matter. Computer simulations confirm this spectacularly. When scientists programmed the laws of physics and gravity, starting with the fluctuations in the cosmic microwave background, and let time advance digitally for 13.8 billion years. The result is a cosmic web, filaments, nodes, voids. Everything emerges naturally just from gravity acting on dark matter and normal matter. The illustrious project, one of the most detailed simulations ever made, recreated the evolution of a cube of universe 350 million light years on each side. It took millions of processing hours on supercomputers. The final result is visually identical to what telescopes observe in the real universe. Astrophysicist J. Richard Gott from Princeton, who studied the topology of the universe for decades, described the discovery of the cosmic web with these words. It was like discovering you live inside a giant living organism. The filaments are like blood vessels transporting galaxies, like cells through the body of the cosmos. And this biological analogy is deeper than it seems. Recent studies compared the structure of the cosmic web with neural networks in the human brain. A 2020 article in the journal Frontiers in Physics showed impressive statistical similarities between the network of neurons in the human cerebellum and the network of galaxies in the universe. Both exhibit similar fractal distributions, comparable densities, and analogous connectivity patterns. The human cerebellum has approximately 69 billion neurons. The observable universe has approximately 100 billion galaxies. The numerical coincidence is intriguing in itself. But there's more. Astronomers discovered that matter flows along the filaments like blood in veins. Hubble Space Telescope observations detected vast currents of hydrogen traveling through the filaments toward the nodes, the galaxy's superclusters. It's as if the universe were feeding itself, transporting raw material to regions where new galaxies will be born. Franco Vazza from the University of Bologna, who led the comparative study between neural and cosmic networks, revealed something fascinating in an interview. What surprises me most is that both the brain and the universe organize only 30% of their mass in connected structures. The other 70% are empty spaces or passive matter that doesn't participate in the network. In the brain, these 70% are water and support cells. In the universe, it's dark energy. And dark energy brings another mystery to the cosmic web, while gravity tries to pull the filaments closer together. Uniting everything into larger structures, dark energy does the opposite. It accelerates the expansion of space, stretching the filaments and making the voids increasingly larger. It's a cosmic battle happening in extremely slow motion. For billions of years, gravity won. The filaments became denser. Galaxies clustered, larger structures formed. But approximately 6 billion years ago, something changed. Dark energy began to dominate. The expansion accelerated. Today, the most distant filaments are moving away from us faster than the speed of light due to the expansion of space. Eventually, trillions of years from now, the cosmic web will be torn apart. The filaments will break. Each galaxy will be isolated in a growing void, losing contact with all others. But for now, the web remains, and it has secrets we're only beginning to uncover. In 2014, astronomers found something that shouldn't exist according to the models. The Hercules Corona Borealis Great Wall structure, a filament so large it extends for 10 billion light years, approximately 10% of the diameter of the observable universe. To give you a sense of the absurd scale, light leaving one end of the structure and traveling at the maximum possible speed would take 10 billion years to reach the other end. Maximum possible speed would take 10 billion years to reach the other end. This challenges a cosmological principle, the idea that the universe should be approximately uniform at very large scales. Structures larger than 1.2 billion light years shouldn't exist according to theory, but they do. So either our understanding of structure formation is incomplete, or there's something about the fundamental nature of the universe we still don't understand. This is where things get really strange. In 2019, a group of researchers using data from the Dark Energy Survey mapped the distribution of dark matter in a giant portion of the sky, and they found something unexpected. The cosmic web is not static, it's vibrating. Gravitational ripples travel through the filaments like waves on cosmic violin strings. These vibrations were predicted theoretically, but had never been detected with this clarity, and they carry information about ancient cosmic events. Supercluster collisions, void mergers, processes that happened billions of years ago. But the question nobody can answer yet is, do these vibrations affect the evolution of galaxies within the filaments? Could there be a cosmic frequency that influences where and when stars are born? And there's another enigma. The voids aren't completely empty. Inside them, there are some solitary galaxies, the so-called void field galaxies. They're hundreds of millions of light years from any other galaxy. How do they form there? How do they survive without the matter from the filaments to feed on? Recent observations show that these void galaxies are strangely bluish, a sign of active stellar formation. But where does the gas come from to form stars if they're completely isolated? A disturbing hypothesis. Perhaps there are dark matter filaments we can't detect crossing the voids. Filaments invisible even to our best instruments, feeding these ghost galaxies with matter we cannot see. If this is true, then the cosmic web we observe is just the tip of the iceberg of a much larger and more complex structure that remains hidden. And now get ready, because there's an even deeper layer to this mystery. In the last 5 years, telescopes equipped with ultra-sensitive detectors began mapping not just where galaxies are, but also the temperature of the gas that permeates the filaments. And they discovered this gas is surprisingly hot, millions of degrees Celsius. Where does this heat come from? The most accepted answer is that when matter flows through the filaments toward the nodes, it accelerates due to gravity. When these gas currents collide in the superclusters, the motion energy converts to heat, like your hands getting warm when you rub them quickly. But the data shows something strange. Some filaments are hotter than they should be with just this process. Is there an additional energy source heating the cosmic web? Could it be radiation from supermassive black holes? Shock waves from supernova explosions traveling through the intergalactic medium? Or something completely different we haven't identified yet? The Zeta Space Telescope, launched in 2019, is mapping X-rays coming from these hot filaments. Preliminary data suggests that approximately half of the normal matter in the universe, the kind that can emit light, unlike dark matter, is hidden in these filaments. Matter that shines so faintly we're only now able to detect it. This means that for decades, when counting how much normal matter exists in the universe, we were finding only half. The other half was there all along, invisible, heated to extreme temperatures, silently connecting all galaxies in a cosmic network of ionized gas. But there's an even deeper implication. If the cosmic web contains so much matter and energy, it may be affecting the evolution of galaxies in ways we've never considered. Galaxies aren't isolated islands evolving alone. They're constantly exchanging matter and energy with the web around them. The web isn't just where galaxies live. It's an integral part of what galaxies are. So here's where we are now. You live inside the largest known structure in the universe. A web of dark matter filaments that connects every galaxy, every star, every atom in the observable cosmos. This structure was born from microscopic quantum fluctuations in the first instance after the Big Bang, grew for billions of years through gravity, and is now being slowly destroyed by dark energy. It vibrates with gravitational ripples that carry memories of ancient cosmic events. It hides invisible filaments that may be feeding solitary galaxies in the voids. It contains half the normal matter in the universe, heated to millions of degrees. And it has structures so large they challenge our understanding of how the universe should work. But here's what will really blow your mind. All of this, the filaments, the voids, the entire architecture of the cosmos, may be just a temporary pattern, a phase in the evolution of the universe. Trillions of years from now, dark energy will have won completely, the web will be destroyed, and the universe will enter a completely different era, with a structure we can't even imagine, unless there's something about dark energy we haven't discovered yet, something that can change everything again, and that something might be hidden in the data we're collecting right now, waiting for someone to notice the pattern everyone else missed. Subscribe to the channel and hit the notification bell, because in the next video we're going to dive into the universe's greatest mystery, the dark energy that's tearing apart the cosmic web. Leave in the comments, do you think we'll discover what dark energy is in the next 10 years? The answer might be closer than we imagine.